Welcome to Math 061 videos. Today we are going to work on solving formulas for a specific variable. So here we have this equation, volume equals 1/3 area times height is the volume of a pyramid. So this is the area of the base times the height of the pyramid. So if the volume is 120 when the area of the base is 60, find the height. So first, we are going to solve this formula, V equals 1/3 AH, for the height. So first we have this 1/3 here, and we want to get the H all by itself on one side. So we want to get the 1/3 to the other side, so we'll multiply both sides by 3. So we'll get 3V is equal to AH. Now, we still want H on one side, and everything else on the other side, because that will solve our formula for the variable h. So we want to get rid of this a. So we'll divide both sides by a. Then we get 3v over a is equal to h, because these two cancel out. So now let's write that up here again. So our h is 3v over a. Doesn't matter if you switch these around, okay, what side the equal sign they're on, because they're equal. So now we're going to plug in what we're given. V equals 120 when A is 60. So our H is going to be equal to 3 times 120 over 60, and that is going to give us that our H equals 6. So what that tells us is when the volume is 120 and the area of the base is 60, our height, h, is equal to 6. And that solves our first problem. So here's our second example. We have this linear equality here, and we want to solve for p. So p is right here. So when we solve for p, we want to get p on one side and everything else on the other side. So the first thing we need to do is get rid of this x that's on the left along with our 2p. So we're just going to subtract an x from both sides then. So we'll get our 2p is equal to, now we have 4x minus x. So that's going to be 3x, and then plus our w. So then the next thing we want to do is we want to divide by 2, because we have a 2 multiplied by a p, and we want to get p by itself. So we're going to divide by 2 on both sides. Those 2's will cancel out, and we get p is equal to 3x plus w over 2. And since all we were asked to do was solve for p, that's going to be our final answer for this one. So here's our last two examples, and you'll notice the first one here we're solving for m, and we have a 3m on one side of our equation and a 2m on the other. So we know that we want m to be on one side of the equation, right? We can't have m on both sides when we're solving for it. So we can just account for that by first subtracting our 2m from both sides. So then we'll get y plus a 3m minus 2m is just an m, then equal to, our 2m's cancel out, so we'll have y plus m is equal to 1. And now we're almost there, so we can just subtract this y from each side, and now we'll get our m is equal to 1 minus y. Now we have m on one side of the equation and everything else on the other, so we have successfully solved this equation for m. So for our last example, we are going to solve the equation y equals mx plus b for x. And later we'll learn that this is actually the equation for a line, and this is going to show up in a lot of math courses, so it's a very, very important equation. So now we're going to solve this for x. So we want x on one side and everything else on the other. So first off, we have to get rid of this b by subtracting b on both sides. So we get y minus b is equal to mx, because our b and minus b cancel out. So now we have this m multiplied by x, so we're going to want to divide by m on both sides in order to cancel those out and get x by itself. So now we get y minus b over m is equal to x, and so we have everything on one side and x on the other, so we have solved this equation. And if we wanted to just write it in this way, x equals y minus b over m, that sort of looks a little bit nicer. In general, we want the thing we're solving for on the left and everything else on the right, just because that's a good way to write it. The one above here is not incorrect, it just looks a little bit more familiar if we write it like the way I just did in the box. And that solves our equation for x.